As the only materials science and engineering program in the state of Utah and the smallest department within the U's College of Engineering, students are able to thrive in environments that nurture their development as engineers while also providing the opportunity to become a part of a close-knit community that includes inspiring professors and alumni working at the forefront of scientific findings.
Hello, my name is Brenda Wicks. I'm an academic advisor for the Materials Science and Engineering Department. There are 2 degrees that are offered in our program. There's the Metallurgical Engineering Bachelor's of Science degree, and then there's a Materials Science Bachelor's degree from the College of Engineering. I've been an academic advisor with the Metallurgy Department for 3 years, and I've been the academic advisor for Materials Science for 1 year. And then the 2 of those programs merged together. There's a lot of similarities between them, so I continue with my academic advising. I want to just discuss a little bit about the interaction between faculty and students. It's been a little bit more challenging with COVID to have some of that just stop in the office and ask a professor a question and so forth. However, I think even during COVID, they have made themselves as available as possible through Zoom and group chats, and are accessible through email. The thing that makes our department and our programs unique is that you are educated in the basics of math, chemistry, and physics. And this is in order to prepare you to take a variety of materials science and metallurgical engineering courses. You can consider these courses tools in your belt of education, understanding, and application.
An important aspect of materials science is trying to predict when our materials will fail, and then to analyze what factors contributed to that failure. Oftentimes, these factors are the result of material processing conditions. There are many tests that we can perform to do failure analysis. In this lab, students use a Charpy impact tester to break samples of cheese and then dry them in a toaster to correlate how the moisture removal in the cheese making process will impact the failure conditions of the cheese. This is valuable information because sometimes, as with cheese, we want it to fail at a certain point, such as when biting down. This lab also demonstrates that there is much more to material science than just polymers, metals, and ceramics, and that we can gain insight into almost any physical object by using a material science perspective.
Hello, welcome to the Materials Characterization Lab. Come on in. The Materials Characterization Lab is a lab full of equipment that we use to characterize materials, obviously. We use the lab for both researchers and industry, so on-campus and off-campus projects. And when people have made a material or a device, they can bring it to us and we help them figure out whether it's working properly or if they need to tweak their design a little bit to get things to work. So some of the machines that we have, obviously we've got some pretty basic like an analytical balance here, but then we get a little more complicated. This right here is a thermal analysis, it's called a DSC. This tells us where there are phase changes, such as from solid to gas or gas to liquid, or any of the combination of phase changes. So DSC, this one goes down all the way to negative 150 degrees Celsius. So extremely cold. We often use it to freeze plastics and see kind of where their freezing point is. This right here is an adsorption analyzer. It helps us know the surface area, the pore size, and the pore volume of very, very small materials. Think about like a foam, a really light, fluffy foam. This could tell us exactly how big the holes are in that foam, down to a couple of angstroms. This machine here to my right, as well as the machine on the other side here, these are both called XRDs. XRD tells us what phases are present in a material. So it's typically used in like mining or geology. They're going to tell us whether there's silicon dioxide or aluminum dioxide or any number of other things in your powdered sample. And this here in the corner, this is a particle size analyzer. It does exactly what you think it does. It tells us the size of particles all the way down to a couple of nanometers. So as we were going through the lab, some of them are in various states of being used or functioning, and the lab is changing pretty regularly. We get new machines all the time. But those are some of our more commonly used and helpful machines. lots of stories from working in the lab. Since we work with so many people, we really get a wide variety of things. We have an internship in the MCL where students of material science and engineering can work for 2 semesters in here. They get class credit for it. They learn a lot of hands-on skills with the machines, and they also get a chance to kind of work with the researchers and the industry people that come into the lab. So about a year ago, or within the last year or so, I had my interns. There were 7 of us. It was midterms, everyone was super stressed, and I had sort of gathered all my interns together. And I had found a dragonfly just dead in my garden, which I was sad about. But I didn't kill it, it just was that way. And then I brought it into the lab and we just did all of the characterization we could on the dragonfly. I had the interns come up with ideas such as how much UV light makes it through a dragonfly wing. What does a dragonfly look like under an electron microscope, which we actually found quite a few little hairs and fun things. What is the surface area of a dragonfly wing, that kind of thing. So we were able to ask a whole bunch of fun questions about this dragonfly, and then they were able to apply their skills on the machines that they had gained through the internship to analyze our dragonfly.
I'm Tristan Lengreen. I'm a student technician at the Roger and Don Career Center for Metallurgy Student Research. We are a facility that specializes in providing resources for student researchers to conduct their research and analyze their samples and do all the things they need to do to be successful in their research projects. We have all sorts of equipment. We have like a BET, a DSC, an SCM, sputter coders, XRD, and I'm in charge of training students to work with those pieces of equipment. We get new ones in all the time, so I've always had to be learning how to use these things and train others. I also run customer samples, so people who need their samples analyzed but don't have time to come in and do it themselves, they can submit it to us, and technicians like myself will analyze that for them and get them the results they need.
University of Utah engineering students also have full access to Lassonde Institute, which offers an assortment of entrepreneurial development programs and equipment, including 3D printers, laser cutting, prototyping rooms, and more to help students pursue their entrepreneurship goals. The NanoFab Lab is yet another resource available to students. Located in the Sorensen Molecular Biotechnology Building, the NanoFab features a range of surface analysis equipment, including multiple different microscopes and a clean room specifically developed for engineering at the nanoscale.
And this is a high-resolution scanning electron microscope, and it's coupled with a focused ion beam. So what this allows us to do is image things at very high resolution. So we can actually image down to about 10 nanometers. Just little snippets of some of the research we've done with faculty, both here at the University of Utah and other schools as well. And so it touches on a lot of different topics. And again, this really speaks to the very multidisciplinary nature of a lab like this. So you can see research coming from metallurgy, coming from bioengineering, coming from electrical engineering, coming from bioengineering again, coming from material science, chemistry, material science, chemical engineering. The list goes on and on. And again, these are the tools that we provide researchers to peer down to scales that are on the atomic level, as you can see here. So a very important helping role we play with lots of different research groups across campus and beyond. Wet processing, so this is chemical etching. And then the orange room you see over there is where photolithography is done.
Students are able to be at the forefront of scientific findings while also having numerous opportunities to connect with other students by joining the various student groups on campus. Among these groups are the Materials Science and Engineering Advancement Society and Materials Advantage, which promote communication among students and their instructors, as well as provide a voice for the undergraduate Materials Science and Engineering student body.
I talk with students on a regular basis and find that they are excited about all of the opportunities that there are in material science. And it's always exciting for me to see that typically a student's sense of curiosity only grows in the program. It doesn't shrink. I talk with a lot of students that are just wowed by all that there is to learn, and